Good afternoon, class. So here's some of the questions that some students have for graphing trigonometric functions. So we'll take a look at that. This one is from the study packet, 5.3, 5.4. So let's take a look at that. It's number started with number 12 on the 5.2 and 5.3 study packet. So number 12, so this one is showing y equals cosecant of theta over 3. So we do know that's a basic form. So first thing that you want to find out is the value of a, which is 1, the value of b, 1/3. And so the period, which is considered 2 pi over 1/3, or 2 pi divided by 1 over 3, so which is 6 pi. And we do know that's cosecant. It's based on the reciprocal function of sine. So first thing that you want to do, you want to start it with the period. Well, let's set up the x-axis, the y-axis. So we do know that here's the x-axis and the y-axis. So we just need one cycles of the graph. So one full period. So from 0 to 6 pi, half of the distance between 0 and 6 pi, which is 3 pi, and half of the distance between 0 and 3 pi, then that would be 1.5 pi, or 3 over 2 pi, and half of the distance between 3 pi to 6 pi, which is 9 pi over 2. So we do know that's a base of the parent graph of sine. Excuse me. So this one started with the vertical asymptotes. So for VA, so we do have one right here, and then we do have another one here in the midpoint, and then over here, the last position, because that's a cosecant. And we do know that the initial height, which is 1, so let's set up 1 right here. Down here, -1. So we do have the vertex at 3 half pi, comma 1. So that's a parabola, like that. And then down here at 9 pi over 2, comma -1. So here's another parabola. Okay, so this one is for number 12 of the packet, 5.2, 5.3. So let's see what else that the students do have for the questions. So number 12, 13, and 23. So 13 is also sketching a graph of cosecant, but this time it's going to be a lot more complicated. Okay, so for number 13, it looks like we have to deal with the Ultima Form. So y equals 3 cosecant of 2 theta, and then plus pi over 4 plus 1. So one thing that you need to do, again, so this one we do know that it has everything, so it's the Ultima Form. So one thing that you want to do, you want to take out that 2 first, because that 2 is like the greatest common factor. So we pull out 2, so we got quantity theta plus pi over 8. And then plus 1. So the value of A, initial value of A, so that's 3. So the base, the scale factor, well, not the base, the scale factor is 2. So H is negative pi over 8, because that's negative over negative, which is positive. And the value of K, then that'll be 1. So find the period. So the way to find the period is 2 pi over B. So it's 2 pi over 2, which is pi. And also we do know that it's the Ultima Form. If that's the Ultima Form, we have to do the one cycle test. So for the parent graph of cosecant, it's going all the way from 0 to 2 pi. And also 0 to 2 pi, they're not included because those are the vertical asymptotes. So basically it's just 0 to 2 pi. Anything that's less than. And also the quantity that we set up here, so we want to put it in right here in the middle. So 2 times the quantity of theta plus pi over 8. So now you want to solve for theta, so divided by 2 first, all 3 sides. So divided by 2, divided by 2, divided by 2. So we got 0. It's less than theta plus pi over 8. and then it's less than pi. Subtract pi over 8, both all three sides. So we do have negative pi over 8 less than theta. It's less than 7 pi over 8. Okay, so now for the rest of this, so we want to set up the template. Okay, so we need the x-axis and the y-axis. So for the x-axis, and then the y-axis. So this one, it goes all the way from negative pi over 8 to 7 pi over 8. So let's set up the scale. So negative pi over 8, it's over here. So 7 pi over 8, it's over here. And then half of the distance between negative pi over 8, 7 pi over 8, then that would be considered 8 pi over 8 divided by 2, which is pi over 2, because this one got canceled. So pi over 2, it's right here in the middle. And then half of the distance between negative pi over 8, pi over 2. So this one is considered 4 pi over 8, 5 pi over 8 over 2, then that'll be 5 pi over 16. And then half of the distance between pi over 2, 7 pi over 8. So we do have, this one is 4 pi over 8, 7 pi over 8, combine them, 11 pi over 8 divided by 2, 11 pi over 16. Okay, so now we do have a VA right on the initial position. So we need to dot the line here, dot it. Here's another one, the endpoint, dot it, because those are the VA for the parent graph. And the midpoint right here in the middle, another VA, vertical asymptotes. So one thing that I got to be careful, so this one, initial amplitude, then that's 3, but it's up 1. So the actual initial amplitude, then that'll be 4. Because 3 plus 1. So 1, 2, 3, 4 up here. But that's just the initial amplitude, but we actually started with the vertex at 5 pi over 16. So 3, that just shows the vertical stretch. So that means the parabola is going to be like this. It's a little bit skinny. And then we do have negative 3 plus 1, then that'll be negative 2. Because that, the vertical translation, so it's up 1. So normally the other opposite initial amplitude, then that'll be negative 3. But due to the vertical translation, so negative 3 plus 1, so negative 2. So negative 2 is over here for the initial amplitude. So we got 1, 2, 3, 4 over here, negative 1, negative 2. Again, just make it a little bit skinny. It's upside down parabola. And here's your graph for number 13. And let's see what else that we have. The next one, we do have number 23. And I believe that one is also considered the Ultima Form for the trig functions. It is. There's going to be a lot of fraction involved with that one too. Okay, so now to look at that, number 23. Again, it's on the same packet. So we do have y equals 1/2. And this one is secant. So secant, which is the reciprocal functions of cosine of the quantity of theta over 2, minus 11 pi over 6. This whole quantity, and then we add 1. So Ultima Form, once again, so let's just rewrite it. Let's take out that 1/2. So 1/2, you can say that's the initial amplitude, but the 1/2 right here, that's a scale factor. So we do have theta minus 11 pi over, well, let's see. We took out 1/2. So we got 11 pi over 3 remain. Because that's a fraction. Because 1/2 times 11 pi over 3, we do have 11 pi over 6. Okay, so now let's find out the all the elements. So initial amplitude 1/2. It's also the scale factor. So B, and now the scale factor 1/2. So find a period. So 2 pi over 1/2, which is 4 pi. And the value of H, horizontal phase shift, 11 pi over 3. So shifted 11 pi over 3 units to the right. But we're going to do that with the one cycle test in a minute. And then K equals 1. So for the one cycle test of secant, it's run between 0 to 2 pi. Also 0 and 2 pi, they're both included. So let's put in 1/2 quantity of theta minus 11 pi over 3 in the middle. So solve for theta, multiply by 2 both all three sides. So we do have 0. It's less than or equal to theta minus 11 pi over 3. It's less than or equal to 4 pi. Again, we multiply by 2 for each term. And then after that, you want to add 11 pi over 3. So we do have 11 pi over 3. It's less than or equal to theta. So 4 pi plus 11 pi over 3. Let's find out what that is. So common denominator is 3. So we got 12 pi over 3 plus 11 pi over 3. So we do have 23 pi over 3. And which is the end point, 23 pi over 3. So once you're done with the one cycle test, so we can set up the template, the x-axis, the y-axis. Okay, so the x-axis. Okay, let's make it a little bit wider. And then the y-axis. So this one started off with 11 pi over 3, so 11 pi over 3, so that'll be somewhere over here. Okay, so let's see. Okay, so you don't want to make that too wide. So this one, 11 pi over 3, so 22 pi over 3 if you multiply by 2. So make sure that got to be relevant and also equivalent. And 23 pi over 3, maybe a little bit over. So 23 pi over 3. Okay, so you can always customize your scale. So you want to make it a little bit wider. Okay, so 11 pi over 3. Well, let's just keep it like that first. Okay, so now another one that we need to find out is the interval. So half of the distance between 11 pi over 3 and 23 pi over 3. So the way to do it is just finding the midpoint, combine them together. So once you combine them together, and then you just want to divide that value by 2. So combine these two values together, we do have 34 pi over 3 divided by 2, then that'll be 34 pi over 6. And then half of the distance between here, so then that'll be those two scale. Again, the way to find it, you can combine those two numbers and then divide it by 2. So just find out those two positions, the value, x value. Again, so this one, we don't start it with VA. The VA would be the next position. So here's the VA. Okay, let's just move that over a little bit. And here's another VA. It's always one spot skip every other position. So you do have the VA. So we do know that this one, it's secant, so it's based off the reciprocal function of cosine. So that means you started with the vertex right here somewhere. But got to be careful. Initial amplitude is 1/2. So 1/2 plus 1 is actually 3/2. So we got 1/2, 1, 3/2. So just make it equivalent. So each scale is 1/2. Down here, negative 1/2, negative 1, negative 3/2. Again, you can customize the scale. So part of the graph, so this one, it's 3/2. So it's approaching to the horizontal, to the vertical asymptote, vertical asymptote. So 1/2, that's a scale factor. So it shows the parabola is a little bit wider. Like that. So that's just half parabola. And the other parabola right here, then that'll be upside down. but let's find out the position for the vertex. So this one normally is negative 1/2, but negative 1/2 plus 1, then that'd be 1/2. Okay, so the graph is being shifted, so it's 1/2. Again, make the graph a little bit wider, because that's the horizontal stretch. Okay, so here's another parabola, because that is symmetrical. And here's your graph. Okay, so again, any questions, any concern that you have, so please put it on the YouTube channel in the column of the comment sections. And then also you can send me the email regarding any questions that you have for the packet, the homework that you've been doing for the list of the packet. Okay, so you guys take care, and I'll see you next time.